Okay, so now we get to figure out our results. We got to give ratios. Okay. I'm going to use a different color here. Let's go blue. All right. So genotype. What you do is you just pick a genotype and then you count how many you have in the 16 squared Punnett square that we have. So I'm going to start with big R, big Y, big Y. Okay, and I'm just going to make a mark to show that I've counted that one. So I'm going to go big R, big Y, and I'm just going to scan. And it looks like that is the only one. Okay, so you'd write 1. All right, let's go big R, big Y, little y. So big R, big Y, little y. Okay, so I see 1, 2, looks like just 2. All right, big R, and then my last combo for the 2 big R's is 2 little y's. And it looks like just 1. Okay, let's move on to big R, little r's. Big Y. So big R, little r, big Y. There's one right here. 2. I'm just seeing 2. Anyone else? Okay, so 1 right here, and then 1 up here. All right, big R, big Y, little y. Connect 4, right here, diagonals, right? So those 4 are taken. And then we have big R, little r.
London Rinky, please come down to the office. London Rinky, please come down to the
4.
office. Thank you.
And then big R, little y's. And I'm seeing 2 for that one. 1, 2. Okay. Little r, big Y. And it looks like just 1 right here. Little r, big Y. 2. 1 right here, in here. And then little r, little y. And it's just 1. Last one. All right. Whew. That was quite a bit. Now, out of all the Punnett squares, I would say this is the worst one. Okay? So we're doing the toughest Punnett dihybrid cross that you could ever come across. Okay? All right, so now we got to do the phenotype. Okay? So we are dealing with his P's, right? So big R, it means round. Okay? You know what? I'm going to type this. This is going to get messy. Big R is round. Little r is for wrinkled. Big Y is yellow. I'll move it so you can see it here in a bit. And then little y was green. Hold on here. I don't think that really helped. Okay. So let's do round and wrinkled first. So I'm going to write round, wrinkled. Holy smokes. Okay, there, made it fit. Okay, so if you're round, that means you have a big R, and then wrinkled, the only way you can be wrinkled is 2 little r's. So, oops, sorry. Round and, what am I doing, guys? I'm supposed to pick a color. I'm supposed to pick a color. Let's go round in yellow, my bad. Of course, it took me all that time to write wrinkled. Go me. Yellow. Round in yellow. Okay, so we're looking for anything that has a big R and a big W. Big Y. Oh gosh. Okay, big R, big Y's. That's what we're looking for. So we go, yep, and yes, no. Yes, yes, and the rest are no. Okay, this is round, but it's not yellow. So now I'm going to count up. 1 plus 2 is 3, 4, 5, 6, 7, 8, 9. Everyone understand how I got 9? I looked at my genotypes, and I was looking for anything that had a big R and a big Y. Okay, so you can also be round, and let's do green. So I'm looking for anything with a big R, but then in order to be green, you need 2 little Y's. So I'm going to make X's for this one. So this one counts. Got a big R, and then 2 little Y's. Big R, 2 little Y's. And that's it. So 1 plus 2 is 3. Okay, so I am done with round. Okay, so now moving on to wrinkled. And let's just do wrinkled yellow. Okay, so wrinkled is 2 little r's, and then yellow is a capital Y. So 2 little r's, yes, capital Y, you bet. I'm going to put a little circle there. 2 little r's, yep. 1 big Y, yep, that counts. So this one does not. 1 plus 2 is 3. What? All right, wrinkled and green, there is just the one. Okay, so remember his Gregor Mendel's data, round in yellow? So round in yellow, if I take 9 divided by 16, because that's how many squares there are, whoops, I get 56%. That's not bad. Wrinkled in green, so 6%, 1 divided by 16, 6.25%. And then the 3 plus 3 is 6, so 6 divided by 16, I get about 37%, 37.5, and he got 38%. Pretty cool. I don't know. I like it when the numbers match up that way. So here's another diagram just showing what you just created, but it shows you a visual, just showing the dominant round and yellow. Okay, and then we got some mixes going on here, yellow and wrinkled, and then there's our one, homozygous recessive. So, yeah. Okay, so what's going on here? So the genes are not dependent on each other, and when genes go through gametes, when we make gametes, they line up independently in random orders. And this is why we have such genetic variation among us in different species, especially in pea plants, where we got mixin, the combination. That's all because of independent assortment, where it shows dominant for one trait, recessive for the other. So this is just a simple diagram looking at 2 pairs of chromosomes, and they try to show you the yellow band and the pink band here. In one scenario, they can line up like this, where blue is all on one side and red's all on the other, and you end up with a combination like this. Over here, blues, you know, they're on opposite ends. And now take a look at that combination. So we have, 46 chromosomes, 23 from mom, 23 from dad. And if you take 2 to the 46th power, that's the number of genetic combinations that are possible. So that's a pretty big number. So in summary of Gregor Mendel's principle, his factors, basically his units, are called genes, and they are passed from parents to offspring. He discovered dominance versus recessive, because that trait disappeared in the first generation and then reappeared in the second. Each organism carries 2 copies of each gene. Okay. That's why we have 2 letters for our genotype, and they segregate from each other when gametes are formed. This works for all organisms, not just peas, flies, humans, cats, dogs, everything. Yeah, okay.